Okay, in this problem we have this 2 kilogram block that's sliding along a frictionless surface. It gives us the velocity. And then we have a second block that's coming faster and collides with the first from behind and sticks to it. So the final velocity of the combined blocks is this value, and they want to know what the mass of the second block is. So what I would do to solve this problem is I would just start out drawing, once again, a picture, and I would do this little sort of before picture and then after picture. And before, I know that I've got a 2 kilogram block that is moving along 1 meter per second. 1 meter per second. And I've got another one coming from behind at 4 meters per second. And this block is a little bit, we don't know the mass of it, but let's see, what does it tell us? The final velocity of the combined blocks is 2 meters per second. Does that give us a clue? Let's see. The initial, we've got 1 and 4, and when they combine, it's slower. So I'm going to guess that it's more massive. So I'm going to say that when they combine together, somehow, this moving along now at 2 meters per second, and we have unknown total mass here. It is, I don't know, and then we've got some mass like this. I don't know, I might have this wrong. Okay, so let's see. No, that's 2. We know this is unknown. And so what we know is that the momentum before, I'll say sum of the m, the individual mass times the individual velocities initially must equal the sum of the individual masses and the velocities the final values, the initial values. So let's try this. So let's say m, which is unknown, times 4 meters per second plus 2 times 1 meter per second. And by the way, this is all, we've got kilograms over here, so I'm just kind of dropping it out of the equation because I know I can divide by kilograms and it will all fall out. It's a shortcut, I know. So m plus 2 and then times 2 meters per second. So once again, I've got these meters per second everywhere. I should have left the kilograms in because, then you could see that it was kilograms. But, okay, anyway, I'm going to do this math here. So I've got 4m plus 2 equals 2m plus 4. So we have, I'm going to go ahead and move this over here, and that gives me 2m equals 2, or m equals 1. Ooh, look, I made the wrong assumptions up here. I thought this was a more massive block when it actually is smaller. So what does that work out here? Let me just check this. So we've got 1 times 4 plus 2 times 1. Is that equal to 1 plus 2 times 2? So we've got, I'm going to put this over here. We've got 4 plus 2. Is that equal to 3 times 2? It certainly is. So it is 1 kilogram. That is the mass of the second block.